All right, day 10. You get the input. You want to find every 0, and then you can only go increase by 1, and you want to see how many 9s you can get. And I, like everyone else, solved it, misread it, and solved part 2 before part 1. So we'll write code that solves both the second and first. So spoiler alert, in part 2 we want to see how many ways we can find each 9. So get the data into a grid. So we iterate over the lines, and then we map each line to the characters, and we map each character to a digit. And it's base 10, unwrap, and we want to subtract easily, so we'll do as size. Collect. All right. So then we want to find all zeros. So we will call them starts. So first we want to iterate over each row, and we'll use enumerate. So we get the ID also. Enumerate. And then we have value, which is the value. Row, iterate over the row, enumerate, and then if value is 0, then it's a start. So then we'll push the value. Okay, so we have each start. No, we want to push ij and as ice size. All right, and then we just want to get all of the for each start, which was called trailhead, want to count the 9s. So starts, and then we can iterate over it, map it, we can call it a point, and then this we want to count, map to a number, and then we want to sum this. Let's sum, and then part 1. Right, so this should write 0, and then we'll do the mapping. So we can create a recursive function. So count paths, and we want to send in the position that we start on. We want to send in the grid, and then we want to know the value that we are that it is currently on. We could read that though, so we don't have to do that. But we definitely want a hash set to keep track of visited, because we don't want to mess with the data. And then we also want another hash set of all of the 9s that we found. So like that. All right, so we can use generate that function, and that's fine. And we should call this like something like visited. And then this would be the result, I guess. And so this will not return anything. Instead, you can call it 9s. And then how many 9s we found, that would be the result, and then we sum it. And so we need to check that this point is within the grid. So we need to get the size of the grid. And then if 0 is less than 0, or less than 0, or n, or m, then we should return. I can just return then we want to see if we have already visited this one. This point, maybe no, it's better to have it that way. Then we also need to return, and so then if data right, we need to have a target, so we can see that we are going to the correct like from 0 you can only go to 1. So, and we can solve part 2 while we're at it. So we'll just have this return a size, and this will be how many paths we could take, and then we'll just discard that for now. And if we actually found 9, so if target is 9, we have already checked that it's the same, then we have found it. So 9s, insert target, p. And we need to return 1 because we found result. So then later we'll add up every child in the recursive function. Yes, everything is correct still, I think. Ice. Okay. Now we need to keep track of where we've been, so we don't move back. I guess it's maybe not needed, but I'm just used to implementing these recursive path findings this way. And then we won't want to count in all 4 directions. So count paths, and then p data target should be target +1, visited 9s. All right, but then we need to modify this one. So it's P0, P1. So +1, -1, +1, -1. So all 4 directions. And in the end, we return count. Bigger or equal 611. That's the first part, and now the second part we have already solved. We just return the count here instead. I think so. It would be a smart idea now to start refactoring this into structures. Have a structure for a grid. Like if we just had a grid and just could write this, and then like find all, and then sum, and then like have a way to get all 4 directions, so you could quickly iterate over it. I think you could have a lot of scaffolding code, and then could do these puzzles a lot quicker, because it's a lot of code just to get started in Rust. But the logic, it's not a lot of logic like in this. Like have a function just to check if a point is in a grid. Yeah.